This is wrong. Let me tell you why you should stop using this command. Welcome to the How to Git MasterClass, where you learn doing it right. Let's get right into it. What are commits? Commits are the main building blocks of a Git repository. In Git, commits are so much more than just a way to save changes. All of doing it right starts with the primary foundation of creating good commits. If we cannot create good commits, everything else just doesn't matter. So, let's start with the very basic question. What is a commit made up of? A commit is made up of several things. It has a hash identifier called the commit SHA. This is a SHA-1 hash computed from all the other parts of the commit. Although it may look random, it is not. If you give the same input for the commit, it will always generate the same commit SHA. For convenience, the SHA is often shortened to the first 7 or 8 characters. A commit will also have a commit author's name and email address, a commit authoring date and time, a committer's name and email address. This is often the same as the other, and if so, many Git clients hide it. A committing date and time. This is also often the same as the authoring one, so many Git clients hide it. A commit message subject line. A commit message body, which is technically optional but often good to have. We'll see later why this is wrong. A diff of changes to the code or text, which can be any combination of the following: added, changed, or removed lines of code, renamed, that is, moved files, newly added files, changed files, or deleted files. Lastly, 1 or 2 parent commit SHA values. This is almost always present, but in certain cases like the first commit of a repo, it can be absent. Most often it is only 1 parent commit, but in the case of merge commits, there will be 2. So, what is a good commit? Now that we know what the parts of a commit are, let's ponder over the question, what is a good commit? A good commit has several important characteristics. It is always singularly focused on a logical set of code changes. What does that mean? In a single commit, there should only be code changes related to either a new feature, a bug fix, a documentation change, or a maintenance chore. It should not mix different code changes related to more than one thing. Now, it has a code diff that is easily readable and understandable. Anyone should be able to view the diff and understand what was removed and what was added in its place. And also why. If your code diff has too many changes, it could be a mess that cannot be read easily. A good commit has a well-written commit subject line. We will go deeper into commit messages later, but in short, a good subject line briefly describes the overall code change, completing the sentence. If applied, this commit will. So what completes the sentence is what the subject is. A good commit also has a well-written commit message body, which adequately describes what the bug or intention was, and what you're doing, why you're doing it, how you managed to achieve it, and what to watch out for. This is also a good place to add links to important online resources that helped you arrive at the solution. And this is why this is wrong. It is difficult to add a proper body if you write the message in the command line. It is not the only thing that makes your commits bad. Stick around and we'll get to what makes bad commits. In the meanwhile, a few more points about good commits. A good commit always gets amended with small additional code changes that are related to the changes already in the commit. This could be through the command to amend the last commit, or by interactively rebasing with squash or fixer commands. If you don't know what these are, don't worry for now. We'll get to those later. The important point is, a good commit will not have a trail of bad commits following it, whose sole purpose is just to make corrections to the good commit. A good commit must always build when deployed, without any build errors. Code editors have gotten so good at linting and showing errors in your code locally that we have no excuse to push incorrect code that fails to build, only to be forced to push another commit just to fix the errors. Now, what is a bad commit? I think you have a pretty good idea now what a bad commit could look like. Nevertheless, let me reiterate. A bad commit could be one that combines unrelated changes together, or it could be corrections to a previous commit. A bad commit could have a code diff that's very difficult or impossible to read. The code diff could replace huge source of code without any context. While there are circumstances where this could happen in good commits, it is often an indication of a bad one. A bad commit has a subject line that doesn't provide any value. This subject line could be empty or be made up of simple terms like commit or fix, or emotionally charged ones like WTF, let's see, oops, please work. A bad commit has no message body or one that doesn't add any value. Sometimes good commits can omit the body if the code changes are tiny or self-explanatory and the subject line is enough. So, this is not always wrong. Sometimes you can use it if you only have a subject line. However, the norm should be to write a good message body. A bad commit doesn't build when deployed. You'll see later why this is a problem. Although rare, a bad commit can also be one which credits the wrong author. In many projects, it's important to give credit to the original contributor of the code changes. If you copy the changes in a commit authored by someone else, you may inadvertently make a new commit with those changes as if you authored it. Git provides ways to change the author of your commit so that you can credit the original author. I must note here that it's not a sin to create bad commits. There are times when you just want to get things working in a hurry and you make several bad comments along the way. This is okay as long as you keep them private and you don't share them with your team or public. Before you share, you should fix up all the bad commits into one good commit. So why should we write good commits? Story time. Recently, I was working on a project and I saw a line of code and I couldn't understand why it exists. Git has a feature called blame, which tells you who wrote this line. I used the feature and I learned that it was me. I wrote the line. Now, looking at the commit I made a few months ago, I still couldn't understand from the commit subject why I wrote that line. That's when I realized I had made a bad commit and I shared it with my team and my future self. Had I added a detailed explanation in the commit message body, my future self could have had a better understanding of the changes in the commit. Git has a feature called bisect. The purpose of the feature is to find the commit which introduces a bug. Bad commits make it hard to use this feature because they are confusing to understand the chronology and often they don't build when deployed. This will make you unable to find the commit that introduced the bug because you will be stuck trying to fix the build errors or manually bisecting two known working commits. Good commits help other team members review your code. By writing the why of making your code changes, you make it clear to them why they should merge the changes into the live deployment. Good commits are essential for generating changelog documents automatically. With bad commits, your changelog would be too long and full of changelog entries that don't make any sense. At this point, you have an understanding of commits, both good and bad. So, how do you ensure that your team makes good commits? You can enforce a commit message structure by using linting tools like commit lint. However, it won't be of much help if your team isn't educated on what a good commit message is. They will only do the bare minimum to meet the linting rules. Share this video with your team so every member in your team can become enlightened on the benefits of learning to make good commits with intention. You're now a master in making good commits. But do you know how branches work? Click here to find out. Or click here to open the masterclass playlist to pick another topic.